Okay. Uh, can everyone see my screen? Uh, can there's only 3 persons here. Oh my gosh. Can anyone see my screen and put something in the chat? Write in the chat if you're seeing or not. Oh, okay. Thank you, Camille. Okay, so I'll just wait until 4 p.m. Okay, you can see and hear me. That's great. And can you see my presentation here? Like if I show my presentation, can you see it? Okay, great. I'll be watching you. Okay, so it's 4 p.m. now. Try to present. I'm gonna present now, but it is official, the official presentation. Can you see it now? I think you can see it, and you can hear me well. I don't need to confirm it again. Okay, so I think I'm gonna start. Okay, so hi everyone. Our topic is about mutation testing, as you can tell by the title. Uh, Let me just introduce myself before the presentation. My name is Thais. I have a bachelor degree in mechanical engineering. I also studied management information technology, and I'm a student of system analysis and a junior software developer. Let me just check once again, one more time, that if you can hear me. Okay, okay, just confirm again. So, so here is our agenda. We're gonna cover the introduction about the disadvantages of code coverage, and then explain what is mutation testing, how to apply mutation testing, show a project implementation, and finally talk about the generated files. So I'm gonna start with the intro, and here I have a question. What is the purpose of code testing? And the answer is to make sure our project's quality is good, right? Okay, but how do we make sure our project's quality is good? Well, there's a lot of projects which apply the code coverage as a metric. And here I have the code coverage definition. Code coverage is a measurement used to express which lines of code were executed by a test suite. So basically that's it. You just need your piece of code to be executed by a test suite. It doesn't check if multiple scenarios were made. It doesn't care if you are asserting anything. And the result is that you don't have tests based on business requirements, which is the right thing to do. You have tests based on hitting a line in a test suite. So that's the metric here. This would be the representation of what we really need. We need to check if all the possible scenarios were executed. For example, here, we would have to make sure the first, the second, and the third scenario were executed, check the asserts, and then finally that piece of code would be considered as fully covered. So wouldn't it be awesome, wouldn't it be great if we could have a tool that could check if our tests have a good quality, check the asserts, check if multiple scenarios were covered or executed. Well, actually we have a tool that could help us with that, which is our Hangouts topic. The mutation testing is a type of software testing which the goal is to test our unit tests. So what is this mutation testing? It is a kind of white box testing because the code is visible to testers, and it is visible because the goal of mutation testing is to improve your unit tests quality. And how does it work? So basically the idea of mutation testing is to generate different versions of your application called mutators. So it really checks your code and generates different versions. Versions with small changes, small bad changes. The goal here is really to introduce some little bugs in the code. But what kind of changes am I talking about? So I think it's important to show some examples. So let's see some examples. It can do some statement changes, like from if true do something to if false do something. That's one possible different version of your program. It can modify operations, for example, from x plus 1 to x minus 1. It can change an equal to a different. Okay, and after these little changes, what happens next? Well, it runs your unit tests against these modified versions. If your test fails with this mutated version, then the mutant is considered as killed. Because your tests, they realize that it wasn't your original code. It was your mutated code. If your test approves this mutated version of your program, then the mutant is considered as alive. But why is it considered as alive? Because your tests were not able to detect faults in the executed code. That's why. It means that your unit test scenarios that you implemented wasn't good enough to detect that some bad changes were made. So basically, killing a mutant means that your tests can realize. They can tell the difference between your program and a faulted version. So the goal, the best scenario you can have, is to have all the mutants as killed. But why is it important? Because anyone in your team, in your project, including you, including me, literally anyone can do, for example, a bad refactoring and can change the feature function. And if your tests cannot recognize a change, it means that we cannot modify our code safely. So just to summarize, mutation testing is a different kind of test that basically generates different versions of your application. And these different versions have some modifications that are basically some little bugs. And after that, it runs your unit tests to check if whether or not they are capable to realize these changes were made. If your tests are not capable to detect changes, it means that you need to improve your unit tests. So it modifies your code, run your tests, check the mutants. Modifies your code, run your unit tests, and check the mutants. And that's it. One more thing that I would like to talk about, I think is important to talk about, is about the installation process. So you can be able to do your own mutation tests. Here we're gonna use the striker.net. The striker.net is a tool that you can use to perform mutation testing for NetCore and .NET framework projects. So let's go to the demonstration where I will show you how to install the striker.net. So I'll stop the presentation here. And here I have my project. I think it's there. I'm gonna, the first thing you're gonna need to do is to go to this page actually. And just to give a context of what is this page, here we have the step-by-step instructions about how to install this tool. And you don't have to worry, I'm gonna leave this link, the link of this page in the description. And the first thing you're gonna need to do is click on getting started. And if I scroll down a little bit, you can see that we have two options here. We have the option to install this tool globally or install it in a project. I'm gonna install it in a project. So the first thing you're gonna need to do on Visual Studio, you have to open a terminal. And you have to go to your unit test folder path, which in my case is this one here, mutation test.unit tests. So you have to copy this first command to install it in a project to create a file called .net2.json in our project. So I'm gonna copy this first command and I'm gonna paste it in here. Okay, so you can see that our file was created successfully. And the second step is to copy the second command. It's really easy. So I'm gonna just copy it in here, space it in here. And it's really important to specify the version that you want to install. I think that if you don't specify, otherwise it won't work. So in my case, I want to install the 1.5.3, but you can install whatever version you want. Okay, so it was successfully installed. And the last step, finally, we have to inform what solution we're going to apply the mutations, which in my case is the solution here, this mutation testing API, mutation tests API, actually. So I'm gonna, I have to type .NET striker and then type solution. And here I have to paste the solution path, which in my case is this one here. Mutation Tests API dot SLN. Let's see if everything's correct. Okay, I think everything's correct. So I'm gonna press enter. Oh, I think I'm not. Am I in the mutation tests? Oh no, I think I did it wrong. Oh, I forgot to go to the unit task folder path. Okay, so I think I have to go to unit task folder path. I'm sorry for that. So I'm gonna just go to this path here. I think I'm gonna have to I'll go back one path. Let me just check it in here. Mutation tests, and then mutation test dot unit tests. Oh no, so I have to go to this mutation tests, and then cd mutation tests dot unit tests. Okay, so I'm gonna just do that over again because I did it wrong, so I'm sorry for that. So first we have to copy this first command and just paste it in here. Okay, and then we're gonna copy the second command. This two package could not be restored. I think it was already installed, so we don't need to do that again. And then I have just specified the solution that we're gonna apply the mutation tests. So I'm gonna type .NET striker and then solution. And here I have to inform the solution path. Mutation tests API.sln. Oh my gosh. Let me see what is happening here. Okay, I think I'm gonna do that over again because it's not working. So I'm gonna just delete this JSON file and I'm gonna just open a terminal again, and hopefully this is gonna work. It's okay. So the first thing you're gonna need to do is to copy this first command, and here I have to go to the unit test folder, which is this one here. So I'm gonna type cd mutation tests dot unit tests. Okay, and then the first command again. Okay, so it is created successfully. Please just work this time. And then I'm gonna install the do striker.net. And here I have to specify the version, and I forgot to specify the version the other time. So 1.5.3. Okay. And finally, we have to inform what solution we're gonna apply the mutations. .NET Striker. And then I'm gonna paste this here. Mutation tests API.sln. Let me see if everything's correct. Okay, I think it's correct. I'm gonna press enter. Oh, I forgot to put the solution. Solution. Okay, finally it is working. Okay, so I'm sorry for that, guys. So here it is informing that our project will be mutated. And here it is identifying that our project will be mutated, the solution and everything. So basically there's no steps left, and it would take some time to load everything. And Gabriel is going to explain more deeply about the project and the mutation testing report, which is basically what is being generated here. So I'll leave you with his great explanation. So thank you very much for your attention, and Gabriel, you can. Oh, and I have just to take a note here that maybe we're gonna have a delay between my presentation and Gabriel's presentation. If that happens, please just wait a little bit. Thank you very much for your attention, and Gabriel can start. Thank you.
Okay, guys, do you hear me? If yes, please just put a okay. I can hear you on the chat box, please. It will be great. Yeah. Thanks, Thiago. I think I can. Yes. Okay. So I think we can start now. So thank you, Thais, for the presentation. It was very helpful, this introduction to mutation test. So right now I'm going to introduce myself a little bit for those who don't know me. My name is Gabriel Brazão. Just a little bit about my education. I have a technology degree in Internet System Analysis and a postgraduate degree in Software Engineering. And today, continuing this Hangouts, I'm going to present a simple solution, but yet explain a little bit about the Striker tool, the Striker.NET tool, using on a .NET solution. Okay, so first of all, I just want to highlight that this solution is a very simple solution. Okay, I created only for the purpose for the introduction of the tool itself. So I'm not focusing code patterns or code quality as anything like that. Okay, so basically I'm only created for the explanation of the striker itself. And the second thing is that I'm using multiple monitors. So if I'm not looking directly at this camera, it's because I'm using the bigger monitor, which have the API itself. Okay, so just a quick introduction about the solution. It's a very simple solution. It's a .NET 5 API which contain three projects. The first one is a mutation test.api, which is an API that has only a simple controller which has an operation inside, mainly because we're going to focus on these two other projects here, which are the mutation test domain and mutation test unit test. Okay, the first one, the mutation test domain, I have a class here, a pretty simple class called calculator, which I have two methods. The first one is pretty simple and pretty straightforward. It's a sum method that I'm going to receive number one and number two, and I'm going to sum these two numbers, and the result of this method will be the sum between those two numbers. Okay, pretty simple, guys. Just for the explanation of the striker.net tool itself. And the second one is a method responsible to define the limits based on 0 and 1999. So I will receive a value there, and this value, I will check if this value is between 0 and 1999. If it's greater than 0, if it's less than 0, it will return 0. If it's greater than 1999, it will return 1999. If it's between 0 and 1999, I will return the value itself, okay? Uh, just for the record, I know that for this method here, we can refactor this method to make a switch case. But for the sake of this explanation, I will leave this implementation like this because I will explain a little bit further on how using refactor we can actually maintain our code coverage and even the mutation test with a nice code coverage. Okay. So the second class, the second project that I want to present is the unit test project here, which is mutation test.unit test. Here I have two classes called sum unit test and threshold unit test. Inside the first one, I have two. I have written down two unit tests using XUnit. It's pretty simple test. I'm basically verifying if my sum method is working using some values, and I write down a happy path test and a unhappy path test, which I'm going to explain a little bit further about those two. Okay, so the first test, this first one is a pretty simple one. So I'm going to receive three parameters here: number one, number two, and the result expected. Uh, I'm going to pass the parameter one, the number one and the number two to the sum method, and as the method purpose, it will sum and response back the result. And the last thing I'm going to do, I'm going to assert if the result is the same as an expected. Okay. And I have the exactly same test written down above, but below, but it's alternative. For example, I have the number one here, I have the number two. I'm going to sum those two numbers. The result will be three, and here I'm checking that the result should not be four. So therefore should be three. So three is not equal four. The test will pass. Okay. I'm focusing on those two tests because that's something that we currently see in our day-to-day development cycle, that every time that I write some method or something that I need to check using unit tests, some developers has the um, always create like simple tests like this first one or even the second one to try to get the maximum coverage for the method or even for the project itself, and that's the problem. Okay, and this is the problem that we are going to try to avoid using the mutation tests. So for example, right now with only these two tests, if I try to execute all the tests, for the sake of this explanation, I'm using the VS test suite and also resharper. So if I go here on my resharper and try to execute all the tests and also cover all my solution from my unit test, as you guys can see it will be builded here. Okay, it's building. So just wait us a couple of seconds just for you guys to see it. Okay, so we have here two unit tests. So we have the first one, the domain one. I have the sum with 100% code coverage. Okay, so it's telling me that I have 100% code coverage from the sum method because I have these two methods working here and these two methods are passing. Okay, now let's see, using the striker.net tool, what are the two results for this kind of situation. So for this, I have a PowerShell open for in my project inside the mutation tests.unit test here. I'm going to run the striker. So I have to give this command here, .NET striker, and we'll be up and running the striker itself. As you can see, he's trying to identify the project to mutate. A new version of Strike is available. This version was available in this week, but for the sake of this explanation, we are using the 1.5.3. But for example, he already found the mutation project that the project that will be mutated, which is the mutation test.domain.cs project. He already made a complete analysis of the project. And based on this and based on the unit test project, he found 5 unit tests that I written for this explanation. Okay, so I'm going to get the striker.net do the works, and then I'm gonna to explain a little bit. But based on these 5 mutants based on these 5 tests that the striker.net found, the striker.net created 9 mutants. So with these 9 mutants, they execute the same suite of tests, changing the code that was implemented, and once again try to find if those mutants are gonna pass it or not. So based on this, we have like 9 mutants created. In these 9 mutants, we have 6 mutants that were killed and 3 mutants that was survived. Okay. And also a HTML report was being generated at that location that I call it the .NET Striker. I have a simple information of the time elapsed for all this process. And for the last but not least, I have the mutation score for the solution, which is 66.67. Okay, so this is a pretty simple and pretty initial information that we have that the tool can provide to us. Right now, let's check out the report that was generated based on this mutation. Okay, so all I have to do is try. I'm going to navigate here to the project. I will open is as a folder. I have already created a folder here. It creates automatically, call it striker output. Inside this striker output, I have a folder created with the date and the time. And inside I have the report. And here I have the mutation report. Okay, so let me open here. It's another tab. Okay, so here I have a complete report explaining what's going on inside my solution regarding the test itself. So I have here all the files that were, all the classes that were tested, a mutation score for those tests. So as you can see, we have like 66.67 percentage of mutation score based on this. And we have also like a chart explaining how many mutants were created, and based on this, how many mutants were killed, survived. We have timeouts, no coverage, ignored, and so on. Okay, so this is also very nice information for us to have. For example, explaining if I want to see how, inside all the solution what this mutation score, it will generate here all the mutation. For the sake of this explanation, I'm only focusing on the calculator.cs. Okay, so basically, I'm going to enter inside this class here that I have, and now that's really the cool part of the striker.net report, that I can have here all the mutants that was killed. It was that were killed, which was 6, and all the mutants that was survived, which was 3. Okay. So, for example, if I want to see which mutant was survived, I only have to check the filter here. And as I can see, I have a snippet of my code explaining where the mutant survived. So for this explanation, I have the method sum here with a red dot here. When I click it, it will show to me that I have a arithmetic mutation survived. So when I executed striker.net, the striker.net analyzed my code, so analyzed the sum method, and based on this information here, the number 1 plus number 2, he created a mutant and changed the operation for a minus. So he tried to see a number 1 minus number 2. And when they executed that test that I created earlier, the test passed, which means that the mutant is survived. So let's analyze and try to understand why this mutant is alive. Okay, the mutant is alive. This mutant is alive because in my test case that I created to verify the sum property, the sum method here, I didn't consider the possibility that this test case can be applied even for a sum or even a subtraction. Let's suppose, let me get a calculator here. If I have 1 plus 0, the result will be 1. So this test will be passed. But if I go here and say that 1 minus 0, the result will also be 1. So this test will also pass when we have a minus situation. Okay, so in that case, for me to kill this mutant, all I have to do is to create another series of testing, another inline data, another case of testing for this. Uh, for example, let's try to use a different one. Let's try to create, for example, this. I'm going to use this, and let's see. I have number 1. Let's change for the number 2 and number 3, right? So let's see if let's try to do like a simple test here. So if I have 1 plus 2, the result will be 3. But if I have 1 minus 2, the result will be minus 1. So in that case, I will assert that my mutant, or my minus mutant that was created, it's going to be killed. Okay, so let's generate again the same report. Let's ask Striker for us one more time to execute this analysis. But this time I will make it easier and I will put minus O here. This is a shortcut that every time that I generate my report, the report will already be open for me. Okay, so once again, let me see here. Just let me see if I save this. Oh, I think I didn't save it. I have to execute again. Sorry about this. Let's go. Okay, so it will be executing again. Meanwhile, I'm checking the comment box. Thank you, Pedro, for the for the compliment. Okay. Uh, okay, it is generating again, but I have to generate again because I didn't save the changes. Okay, so I'm going to execute again one more time. Sorry about this. So once again, let me execute this again. And once again, I will have the striker.net up and running. Once again, I will have the analysis being made inside my project. Okay. The great thing about striker.net also is that every time I create a new test, he already found a new test about this. So initial test run was started, 9 mutants was still created, 9 mutants will be executed. As as we can see right now, it will generating all these mutants and explaining how many mutants were killed, how many mutants do we have survived, and so on. And for example, now we have a percentage of a score of a 77.78 percentage of mutation score. And if I go here on the calculator again, as you can see, I don't have any more the mutant survived. This mutant is already on the killed pile. So if I go here and execute the filter for the killed, I will see that that red dot that was earlier, now it's a green dot. And if I click here, it will explain that arithmetic mutation was killed in this case. So we already treated this kind of information here. Okay, so this is a pretty simple example for me to explain how the arithmetic mutation works on the striker.net. Okay, I have another example and another method, which is this method here, the I calculator, where I have actually, this is the right, where I have the define limits one. So basically, I'm passing a value here, and I'm asking for the method to check if this value is less than 0 or greater than 1999. If case yes, it will return 0 or 1999. Or in this case, if it's between those threshold, between this threshold, it will return the value itself. Okay, so for this, I created another suite of tests here, explain a little bit on the define limits. Like the other, I'm using the same approach of the three A's, arrange, act, and assert, but in this case, I'm only using the act and assert, okay, because the arrange itself, it's an inline data, okay. So for this, I created three suite of tests. So the first one is testing if I pass a value greater than 1999. The second one is a value less than 0, and the third one a value between the threshold, so 0 and 999. So this is my expected scenario when I pass 1000 should return 1999. When I pass minus 11 should return 0. When I pass 35 should return 35. Okay. Once again, I'm gonna execute those tests in my resharper tool. So I'm going to see the cover of it. Okay, so let's see. It's executing again. So I think I have a define. Let me just, oh, right, yeah, now it's clear. So I have 100% of code coverage for this define limit, as you guys can see it. But let's see in my report for striker.net what are the results that is telling me about using the mutators. Okay, so I'm going to execute again the striker just for the sake of this explanation. We don't have to execute this all the time. I'm only executing for explain a little bit all the changes that I'm doing. Okay, but once again, he's starting to execute the files and everything that is currently being used. So let's just give us a couple of minutes here, even seconds, I think, to execution of all this. Uh, Meanwhile, I think we have a question. What happens if the mutated version of a method is functionally equivalent to the original method? Um, so for example, let's suppose that so let me see if I get this straight. So what happens in the mutated version of a method is functionally okay. So in that case, the striker.net will not create a mutant that has the same behavior of the original implementation. Okay, he will only create a mutation who is different from the original implementation. So for example, as you can see by that example of the plus and minus scenario, he didn't create a mutant for the plus, only for the minus, because he already knows that the plus is working on that test that I created earlier. Okay, so once again, I have the calculator here, and right now I have two survived mutants. Okay, and as you can see, the surviving mutants that we have here are in the defined limits. Okay, so this is a very good example that I try to bring here, because the beauty of the striker.net is, for example, we don't have always to try to understand if it's the problem is only in the unit tests. So for example, right now I have the two dot the two red dot um, the two red dot explaining what is the defined limit. So for example, if I click here, I will see that it was created a equality mutator of greater or equal 0, less or equal 0, sorry, and a greater or equal 1999. So this is a very good example that I brought here, because sometimes it's not only the unit test that I have to check it. It's also necessary to see if, for example, I have something related to the implementation as well of the rule. So that's something that we should also consider when we are using mutation tests, that we are not going to only analyze the unit test. We also have to analyze sometimes the method itself. So for example, if I need that define limit should coverage the greater or equal and the less and equal this value, I should change my implementation for these kind of things and also write tests. Or in case not, I should write tests that for this kind of particular case, I can deal with this kind of situation. So this is an example that I brought just to explain that sometimes I don't need only to verify the unit tests. I need to verify the implementation itself. Like I said, if I try to use a switch case here, try to refactor this define limit to a switch case, all this problem will not occur because switch case are defined, which switch case I can define those limits, and using switch case I can kill those mutants. Okay. I have another example to explain to you guys. Let's suppose that, for example, I have here, I want to create a different set, a different method that I want to check in my that I have in my API, but I didn't write any test for this. Okay, so let's suppose I'm going to create a new method, but instead of sum, I'm going to try to divide. Okay, so for the sake of the time or the explanation, I'm just going to copy this method here and paste it. Okay, so I'm going to change, so method responsible to perform a division between two numbers. Okay, sorry, I have a typo here. Division between two numbers. The first number in the division, the second number in the division, and the division between two numbers. I'm going to rename this for division. Okay, and okay. So let's suppose that I have this method created here, but I won't write any test for this. Okay. Uh, so let's see what striker.net will do. I know that for example, ReSharper or even Visual Studio, if I go here and try to cover all tests for my solution, it will show to me that, for example, the divide method doesn't have any test. So let's see how it's going to work. As you can see, the division, I don't have any coverage because I didn't write any test. Also for my unit test session, I didn't have anything here. Okay, let's see how striker.net behavior with this specific scenario. So I will once again execute the analysis of the striker.net. That's the great thing. I think it's one of the nicest feature that striker.net has. That, for example, as you can see, it will generate again, and it will generate the same suite of tests, but let's just wait a second. Okay, so initial test run was created, but this time 11 mutants was created, but he already sent us a message saying that 2 mutants got status no coverage because that mutant has no test coverage. So let me open here once more. So it even we didn't have created a unit test for this, Striker.net already found those methods and already created mutants for this kind of method. So he already said that, for example, I have seven mutants that was killed, 2 survived, and 2 got no coverage. And I have the time elapsed here, my final mutation score. And if I go on my report here, I will see, for example, that now I have a no coverage filter here, that if I want to see what's in the no coverage, I will see that the division, we don't have any coverage for this. And if I go here on my, now it's a orange, it's a orange circle, it's an orange dot. If I click here, I will see that he already created a mutant for this kind of operation. So like the minus and the plus, he now is changing the division to a multiplication and trying to execute them. So that's the beauty of also the beauty of the striker.net. Even if I don't have the unit test, the striker.net already found the method itself and already created a mutant. So right now, all I have to do is try to create a unit test for this that I can came up with a solution, a solution that will explain and also execute this unit test in a way that I can use the division method for this unit test. So Striker.net already deal with this part of no coverage, and it it deal it deals with such a good performance because it already knows that the division is not having any unit test, but already created a mutant that when when this unit test of the division is eventually created, that's the test that he will execute it. That's the mutant that they are going to execute it. Okay. So basically, this is the kind of explanation that we prepared for this presentation. We only dive in a couple of basic examples like arithmetic and equality operations. I I stimulate you guys that if you guys find very interesting this part of mutation test or even Striker, please go to the documentation itself because the mutators that Striker can generate, it's very the list is very big. We have like literal mutations that can be created, link Q, equality, arithmetics, and things like that. But for this initial contact for the striker.net, we prepared these three scenarios. It's just for instigate you guys to understand that even when we are seeing some unit tests in our code coverage saying it's 100%, it's very nice to use a tool like striker.net and the mutation test methodology to see if the code coverage is really it's a real number, it's a real day-to-day scenario because we can be very surprised. Okay, I know that we use some very simple examples, but imagine this on a very complexity code. How many breaches can we find and how many bugs can we avoid using this kind of tool here? Okay, so I my request for you guys, if you guys like this presentation or even like the strategy, the methodology itself, please go see the documentation of strike.net, which is very helpful, complete, has a lot of examples, has a lot of implementation examples. It's not only using a .NET. I don't know if you have someone from the community of JavaScript or Java, but I know that the striker has support for this kind of languages. So please feel free to share any knowledge. This project is besides it's a very simple project. I will share it to you guys for you to try to understand how it's working. But this is our presentation. This is I think we can finalize from here. I will leave you if guys having any questions, want to say something in the uh, wants to say something in the comment box, please feel free. And in case not, please feel free to share an email or even to ping me in Teams or LinkedIn, whatever. But please feel free to also to look into mutation tests because it's a very nice methodology and we don't see these kind of things every day getting used, and it's very helpful for us developers or even QAs on a daily to day development and implementation process. Okay, so I'll leave you guys with all this information. I want to thank Thais for the first part of the presentation, which was amazing for the introduction. What is mutation test? Thank you all for joining here today. And I don't know. Thanks everybody for being here. And that's it. If you guys have any questions, please feel free to ping me. And I guess that's it. Thanks everyone for joining, for participating today. Okay. Yes, that's it. Okay. Thank you. Thank you all.